Hello and welcome to another video. In this video we're going to be working on copy list with random pointer. So in this problem you're given a linked list of length n, and it's a normal linked list except now every single node has a random pointer as well, and that pointer can point to any other node in the linked list or it can point to null. And your task is to make a deep copy of a linked list, meaning all the nodes have to be just like these, but you have to use all new nodes and they have to point to the new nodes. They can't point to old nodes. So for this first example, I mean, it's hard to exactly show it, but essentially for a list like this, you're making a deep copy. So you're making all these 5 elements that point to each other. And for these, kind of the same thing. So let's actually draw this in a different way to make it maybe a little bit easier. So we're going to have 7, 13, 11, and 10, and 1. And then I guess we'll have null at the end because some things do point to null. So this points to null, and 7, as you can see, points to null. So let's draw that with another color. So the random pointer of 7 points to null, the random pointer of 13 points to 7, the random pointer of 11 points to 1, the random pointer of 10 points to 11, and the random pointer of 1 points to 7. So we'll just do it like this. Okay. So how do we essentially do this problem pretty much, right? And it's not super easy, obviously, but like how many different ways can we do this for just this one example? The rest of it is the same thing essentially. So if you want to make a deep copy, there's 2 things you can do that are pretty straightforward. One is you can just make a copy of every single node, and then you can store it in a hash map. So essentially, we can just ignore all these randoms, right? So essentially, we can just go through this list, and for every node, we'll just store it in a hash map, and then we'll make the next pointer point to whatever that is in the hash map. So let's show what that's going to look like. So the hash map will just have like nodes, let's say, and essentially what's going to happen is we're going to go through this whole list, ignoring the random pointer for now. And we're going to go through it and we're going to say, okay, well, node 7, is that in the hash map? No, it's not. Okay, so let's store node 7 in the hash map. And what do we want for the value? So for the value, we will make a completely new node and we'll represent it with 7 prime. But essentially, it is just a new node with the same value, right? And then for, yeah, so you can keep doing that. So for node 13, you would also make a brand new one, 13 prime, 11, 11 prime, 10, 10 prime, and 1. And now it's pretty straightforward for the rest of it, right? So for these new nodes, first you make their next and null pointers, or null and random pointers, equal to none, right? So for now, they're going to equal to none. But then we're going to do one more pass. You can do this in one pass, but it's easier to explain in another pass. So essentially, first pass, you just loop through this list, and every single node, you create a new node, and you store it in the hash map, right? Key is the old node, new, and then new node is the new node. Then we make one more pass, and we just say, okay, for every node, we'll take its next pointer, figure out where that is in the hash map, and we'll make the next pointer of the value go to the same place. So for example, the 7's next pointer is 13. So we can just say like, okay, well, if the 7's next pointer is 13, that means this 7's next pointer should be whatever the value is for 13, right? So we can do this. So essentially the next, we'll call that n, is 13. And it's easy because we have this hash map, right? So if we know that 7's next is 13, it's always going to be in the link, it's always going to be in the hash map. We can just say like, give me the key for the next pointer, and then the next of the value is going to be the other value, right? And what about the random? So 7 points to null, so that part is just going to be defaulted to null. So we'll call that r is null. Okay, then we go to the next node, 13, and we say, okay, what's the next of 13? Well, it's 11. So we'll just say, okay, well, if the next of 13 is 11, the next of the value is going to be whatever the value of this is, right? So the next of 13 will also be 11. Pretty straightforward. Because we can just use these keys to figure out where, like, we can use these keys to get the mappings to know exactly where to go to. And then where does the random pointer of 13 go? Well, it's at 7. So once again, I can get this key 7, get the value 7, and say, okay, well, the random of this should be the value here, right? So that's going to be 7 prime. And then for 11, same thing. So 11 goes to 1. So it's going to be this. The next is going to go to 1. And the random goes to, 11 goes to 10, and the random goes to 1, right? So it's going to be 10, random 1. For 10, it's going to go to 1, and its random is 11. So next 1, random 11, and so on. And for 1, it goes to 7, and its next is null. So next is null as default, and random is 7. So that's one way to do it, right, with this hash map. But we are going to show an in-place solution. And pretty much what we're going to do for the in-place solution is it's going to be a little bit different, but also not too hard. So instead of having this hash map, what we're actually going to do, let me actually get this and delete this hash map section. We are actually just going to go through this once again, one pass, and except now, after every node, we will create a new node with the same value. And it's going to have a random pointer going to nowhere. So let's show what that's going to look like. So we're going to have 7. Let's actually use this color. So we're going to traverse, and for every node we get, we're just going to create a node in place right after it with the same value. And then its random pointer will be pointing nowhere, and then its next will just be whatever the next node in the list. So essentially we will be at 7, and we're going to say, okay, well, now that we're at 7, let's create a new node after 7 with the same value. And let's make that 7's next pointer now point to 13. And then we go to 13. We do the same thing. We make a new node with the same value, and we make this next pointer point to 11. So essentially you have something like this. 11, 11, 10, 10. And it's pretty straightforward doing this, right? So putting a new node is pretty straightforward. You can just say, like 7.next equals new node, and then that node has value of 7, and then its next value is 13, right? So that's pretty straightforward. Okay, so we have 10, we have 10, and we have 1 and 1. Okay, so now essentially we have a list of 10 elements. Now these random values are going to stay the same, right? So 7 points to null, so let's actually put a little null here. So 7 points to null, but this new value doesn't point anywhere, right? For now, essentially. Like we just did a one pass, its new value doesn't point anywhere. So we are going to do a few passes through this, but it's okay, it's still going to be the same time complexity. So 13 points to 7, this first 7, right? Same thing. And then 11 points to 1. And then 10 points to 11. And finally, 1 points to 7. So we're going to loop around again. So you can see like these newly created nodes, these, maybe we can even give them a little color to symbolize that they are the new nodes. So these newly created nodes don't have next pointers yet, right? Or sorry, they don't have random pointers. They have next pointers, but they don't have random pointers. So we do have to give them next pointers. And how do we do that? Well, that's also really straightforward. So we can just traverse the even nodes. So we can just say like, okay, you know, let's just start over here. And let's just actually, so let's say we're traversing. And let's say we're going to do this color. We're just going to start over here, and we're going to traverse until we are null. And we're going to traverse every other node because we want to traverse original nodes. And we'll just say like, okay, well, here's what we can do. So if 7 has whatever random value, we can just say the node after 7 has the value of the random value of 7.next, right? Or if its value is null, then we'll set it equal to null. So for 7, its random value is null. So the node after 7 will have a random value of null, and we will represent it with this arrow here. So it's going to be null. Then we will traverse over here, and we're going to say, okay, does this have a random value? Yes, it does. that means that the random value of the node after it will be the random value of whatever this is, but it'll be the next node, right? So we can write that down. So random value of node after cur equals random, or I guess, yeah, it's random, right? Yeah, random pointer. So random pointer will be random pointer of cur, and then it's going to be dot next, right? So whatever the cur points to, it's going to be the next one. And that's because these are all duplicates, right? So if 13 points to 7, that means this 13 needs to point to the next 7. That's why you just go to whatever random value points to and you take the next one. So this 13 will point over here now. And then we go to the next node, right? So we traverse every 2 nodes. We can just say like cur.next. Now we are over here. And we're going to say, okay, does this 11 have a random pointer? Yes, it does. So then this 11 is going to have a random pointer that's going to be whatever this is pointing to, but the next one. So this 11 will point over here. And then we will go to the next one. 10, does it have a random pointer? 11, okay. So then this next one will point to the next value right after 11, which is over here. And then for 1, same thing. It's going to point to the 7. So I know there's a lot of arrows, kind of confusing, but that's essentially what it is. So now we have all our random pointers set up, and you see that these new nodes, these brown random pointers, are pointing to only new nodes. And now essentially we have a list of old node, new node, old node, new node, old node, new node, and so on. So now all we have to do is just split it up. And so when we originally created this list, I forgot to mention, we're going to have a dummy node. So we'll just have some dummy node point over here. Pretty straightforward. And now essentially we need to break this list up into the original list and the new list, right? We want to like maintain the structure of the original list ideally, because we want to like give the inputs the same way they came. So what we can do is we can just make a new dummy node. We'll call that like new list or something. And essentially all we have to do is just go through the old list. So we just go through the old list. So you could do this one of 2 ways. You could do this by making 2 new lists, or you could just take this original list and use that for the old list, and then this is going to be the new one, and then that's what I'm going to do. So essentially you start once again at the very start over here, and you just say, okay, as long as that's not null, the next pointer of whatever I'm at needs to go to the new list. So this is going to have this new 7. I'm not going to show the random pointers, but they will still be there. I'm just not going to show them in this because that's just too much stuff. So essentially the next pointer will go to the new list, and then just make the next pointer of whatever I'm currently at, instead of its next, make its next, right? So essentially that will get rid of this in here. So it will do this. And then we will be at this node, and once again, we want to do the same thing. We want to split it up, right? So we're going to say the next pointer of this is going to go over here. So we're going to put 13 here, and then the next pointer of this, make it, instead of this dot next equals 13, you can just say something like cur.next equals cur.next.next. And this one line will essentially just update this pointer to point over here. And so that's what we are going to do. And so we will delete this section, and now we will have the pointer like this. So I guess maybe I should draw these in blue, because it's a little unclear. Essentially, this is blue, blue, and then same thing. Here we are at this node, so now we need to say, okay, let's take the next of this and put it in the new list. So we're going to have 11 over here, and then once again, 11.next equals 11.next.next, which will make it point to 10. So we are going to get rid of all this, point to 10, and then same thing, right? So this points to 10, and then this is like this. And for the 10, same exact thing. So we're going to put in the 10 over here, the second 10. And then we need to do the same thing here. So we need to make this next point over here. So we will do that. But yeah, if you want to do this using 2 lists, that's totally fine too. Like you can make 2 new lists and you could split this up that way. Okay, and now finally for the 1, we are at the 1. So one last time, we need to put the 1 over here. And finally, this 1 will now point to null. So now points to null. And so these brown lines, they will persist in these new nodes. Like these new nodes, random pointers will still point to each other. I just haven't drawn that. So when you move these like pink nodes around, their random pointers will persist. It's just their next nodes will change. And also similarly, the random pointers of these original nodes will persist. So now we have the old list and we have the new list. And now we simply just return the new head. So that's essentially the steps. Let's go over it one more time, right? So you take the list and you put in a new node after every single node that's just going to have the same value as the node originally had. So you'll have like 7, 7, 13, 13, 11, 11, and so on. Then to get the random values for the new nodes, you just take whatever the random value was for the old node, the one right after it. And then you just say, let's take whatever that is and let's take the next of that one because that'll essentially be the new node. So you're essentially doing like an in-place hash map where you could say like, okay, the node I'm currently going to, the new node is going to be the one right after that. So it's kind of like the same thing as a hash map, only you're doing it in place basically by making these connections in a linked list. And then finally, when you do have this list of new node, old node, old node, new node, old node, new node, and so on, then you just break it into 2 lists and you return the new head. And now notice our old list still has the original structure that it came in with, right? So 7, 13, 11, 10, 1, the original list here. And it points to null. So we basically manipulate our input, but then we kind of change it back to be what it was. Okay, so now we have enough to code it. And I will say, doing it in place is definitely tougher. So I think that's like getting to the harder. There's not too much code. And I will also say when you do this, I would strongly recommend drawing this out as you go. Because once you get enough, like once the complication gets big enough in linked lists, I feel like it's really hard to visualize exactly what's going on and it's easy to make mistakes. So I would like write out code and then maybe do like a dry run of like, okay, what does my linked list actually look like as I go just to make sure it's correct. Because it's very easy to run into errors. Okay, so we can actually get rid of all, actually we'll keep this for now. And also, yeah, you want to keep in mind the initialization for the node because they're different all the time. Like here, you do have to give it an X value, it's not optional, and then it also takes an X to the random. Okay, so essentially we're going to make a dummy node first. So it's node, and we're going to give it some value, and then it'll point to the head. And now we will essentially take that original list, and we will just insert a new node after each original node with the same value, and just a random pointer equal to null for now. So we can just say while head.next equals node, it's going to take head.val, and then it's going to point to head.next, right? So if you have something like 7, 13, whatever as your nodes, essentially you're putting in a 7 here and you're saying, let's let that 7 point to 13. And now we'll let this original 7 point to 13 by saying head equals head.next. So this original 7 points to the new 7, and then this new 7 will point to the 13, and then we want to iterate 2 nodes forward because we made a duplicate. So that's going to give us our list of new node, old node, new node, old node, new node, old node, new node, and so on. Then we need to traverse through it and put in the random pointers. So, and the easiest way, that's why you want to do it in 2-pass, because you don't want to like, if you don't do it in 2-pass, you might try to put a random pointer to a node that doesn't exist yet, right? Like if you have some nodes, like 1, 3, 7, whatever it is, like the random pointer of this might be all the way over here, and then you don't even have that new node created yet. That's why I'd recommend doing it in a 2-pass where you create the nodes first, and then it becomes a lot easier to put in the random pointers. And once you realize that, I think it makes it a lot easier to figure out how to do the random thing, that you can just do it in multiple passes. Okay, so now we are going to do another pass, essentially, where dummy.next will be the new head of the list. So we can just say while cur, if cur.random, meaning if the node, so we're going to traverse old nodes, and if the old node has a random value that's not equal to null, then we're going to need to update the random value of the new node. So we can do this, cur_next.random equals cur.random.next. And that's essentially because the random pointer of the new node is going to be the same as the random pointer of the old node, except it'll be the node right after that, because that's the clone node. Okay. And then we are going to do the same thing. We're going to move it up 2 nodes at a time because we only want to go through the old nodes. So now we need to split up this list into the new list and the old list, and we're going to keep the old list in place. So we can just say new list equals node 0, and then we can make a cur So cur new cur equals dummy.next is where the whole list starts, the new and the old combined, and the new list will be, this new cur will be where the new list will go. So we could say while cur, and then we need to essentially break this list up into both parts. So we can say new cur.next equals cur.next, meaning if we're at some node, the node we want to add to the new list is the one right after cur. It's the new node because we're going to be traversing old nodes. Then we could say cur.next equals cur.next.next. So essentially we're saying, you know, if we have something like this, 7, 7, 13, 13, when we do cur.next, let's say we're on 7, it's cur.next.next. Essentially we're saying the 7 now points to 13, so we got rid of the duplicate. And then we need to say cur equals cur.next to actually move up to the new node. And finally, we need to say new cur equals new cur.next to move up on the new list as well. And then we need to return the new list.next because new list will be the dummy head of the new list. And I think that's it. So let's see how this goes. Next. And yeah, you don't have to check for like next.next because assuming your list is always going to be an even length, there will always be like a next.next or it'll be null. So okay, let's take a look. So we can see it's reasonably efficient. And like I said, you do have to do multiple passes here. Maybe you can shorten a pass, but the time and the space is still going to be the same. So here, for the time, it's going to be, we're basically doing like a few passes through this old list, right? And then sometimes we're passing through a new list. So if the old list had n nodes, sometimes the pass will take n time, sometimes it'll take 2n time, but whatever, you know, you'll have some multiple of n, which rounds down to n. And then for the space, we are making new nodes, but that's part of the result, so those don't count. And then we are making a few dummy nodes, but we're only making 2. It's not like proportional to the size of the list or anything, it's a constant number. So the space is going to be O1 for this one. And yeah, so hopefully you got that one. And like I said, once you realize that you just want to fill out these randoms after you create the whole copy, it becomes a lot more straightforward. I think that's the toughest part of this problem is like trying to fill out these random nodes before you actually created the new nodes, and then you'd be like, well, I didn't create it, how do I go through that? So yeah, that's going to be all for this one. Hopefully you liked it, and if you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.